This meeting is being recorded.
Okay, so in yesterday class, we discussed about different types of redundancy protocols that help you to have multiple different gateways so that we can have backup path when the primary path go down. So that's why we need HSRP or VRRP or GLBP, right? So what happens if the HSRP or GLBP doesn't support means that the gateway will have no redundancy, and that will cause outages when your primary router go down. But if you don't have the budget to buy two routers as your gateways, for example, if you own a small shop and you don't want to buy two routers, and if you're okay to go your router to go down, then there is no need of HSRP or VRRP or GLBP, because you are taking that risk that if the router go down, you are okay to let it go down, and you are accepting the outage, you are accepting the risk of going your network down. But ideally, when your company is bigger, when you have big employees, you don't want your network to go down. For example, let's say there is an outage on one of your ISP, you don't want your network to go down completely and not rely on the ISP, right? Or one router. So in that scenario, you will use a backup path. For that, you will use HSRP or VRRP as your gateway, and GLBP, as you know, you can do some load balancing by using the round robin or hosted pin entry like that. So let's ask a couple of questions. Divya, can you tell me what is preempt?
The one which has more priority than standby, like we use preempt when it says when this one of the system goes down, like the active or something, then preempt takes place, like saying it's the boss, like it's in the active mode.
Yeah, so when the active router go down and when it comes back up, the preempt will make sure that the active router will take back its active role because it has preempt enabled, so it will take back the active role. If the preempt is not enabled, the backup router will stay active because the primary router went down and it came back up, but still it will not become the primary because the preempt is not enabled. Okay. Hari, can you tell me what is gratuitous auth?
In the HSRP, when one of the gateway goes down and the other is up, to notify the other gateway, we use gradations R table.
Yeah, that is correct. So when the router go down, to tell that to the downstream peers that the MAC address changed for the primary, so that the next packet will be reaching to the secondary router. So to update that, it is called gratuitous auth. Yes, that is correct. Okay. Nagarjuna, can you tell me how does the GLBP load balance?
Yeah, in GLBP, it follows like a load balancing. It will send one packet, by one router and another packet with another router, another active gateway. Like that, it means like round robin. It follows round robin.
Okay, got it. So it follows round robin and it sends the packet to one router to the other. So it will send the packet to the virtual IP, and the virtual IP will load balance to both the both the routers, active.
Both the routers.
Yeah. Okay. So today's topic is spanning tree flavors, and what are the different types of spanning tree, and how do the spanning tree got better over the time. So let's see. Mohit, is this your first class?
Yes, this is my first class.
Have you gone through all the recordings?
Not yet. I haven't got them yet. This is the first class in the afternoon. We just planned to join, and I just joined just to see how things work.
Okay, I think you need to do some push.
Yes, I'm gonna have my homework in some time, but yeah.
Okay, all right, try to catch up then.
Thank you so much.
Shruti, can you tell me why do we use spanning tree?
Loops. To
Sorry,
avoid the loops between the switches.
yeah, to avoid the loops between the switches. So, okay, thank you. Sai Sri, can you tell me how does the spanning tree avoid the loop? What is the mechanism behind it?
Okay, see, we use the BPDU like protocol between the switches to get the priority number, so that the like lowest priority will be the root bridge, and we'll choose the like shortest path to send the packet to the final one destination.
Yeah, so basically, spanning tree will elect the root bridge based on the BPDUs. They will exchange the BPDUs between the switches. So whichever switch has the lowest priority, that one will become the root bridge, and it will start allowing those ports. And the non-bridge ports will have one of the blocking port. That's how it avoids the loop. That is correct. So let's stop it there, and we'll start today's class, because today we are talking about the betterment of spanning tree. So let's talk about that. Let me start sharing my screen. So to recap, let's say there are 3 switches. So when they are connected in a looped fashion, when there is an connection like this, there is a chance of having a network loop between the switches, right? So to avoid that, we have to put one of the port in the blocked state. So what they do is the switches will exchange. Switches will exchange the BPDUs. Switch 1 and switch 2, they will exchange the BPDUs, and switch 1, switch 3 exchange the BPDUs. So does the switch 2 and switch 3. They all exchange the BPDUs. BPD is nothing but bridge protocol data unit. It is a message that is exchanged between the devices. So they will exchange the priorities. BPDU is nothing but a combination of priority plus MAC address. So let's say the priority is 100. The priority is 110. The priority is
Jumbo, అక్కడనే ఉన్నారా స్టార్ట్ అయిపోయారా?
Hari, can you mute?
ఒక పన్నీర్ బిర్యానీ తీసుకొస్తా.
Hari, can you mute, please?
ఓకే.
Okay. So the switch 1 will talk to switch 2, and switch 2 will talk to switch 3. They all exchange the BPDUs, and whichever has the lowest priority, in this case switch 1, that one will become the root bridge. Okay, now the switch 2 will see talk between switch 2 and switch 3, and because this one has the low priority, that one will become the next selected root bridge. And then the third one will be this one. So this port and this port will be in the forwarding state. The port that is closest to the root bridges are will be in the forwarding state, because for the switch 3, the closest port is this one to the root bridge. So this one will be in the forwarding state. For switch 2, the closest to go to the switch 1 is this one. So this one will be in the forwarding state. So now either this port or this port will be in the blocked state. So because of these priorities, the switch 2 will have the lower priority. So this is the second root bridge that will be allowed, but this port will be blocked. That way the traffic should always go like this. This port will be blocked. So that's how the spanning tree will avoid the loops. You already know this. That's why I breezed through this, because you already know this concept. But this is the traditional spanning tree. Before we talk about advancements of the spanning tree, let's talk about spanning tree states. The spanning tree states mean, so when they exchange the BPDU, there are different states the spanning tree has to go through. Meaning, let's say, let's for easy purpose, so let's take, there are two switches, right? So this is switch A, initially switch B. So let's talk about the first state. The first state is disabled state. What does this do means, in the disabled state, both ports are administratively down. What does administratively down means? This port and this port, this port and this port are manually down, like shut down. They are like no power to that port. We manually did the shutdown. So when this port is in the shutdown state by the user or the administrator, the spanning tree will never start because the port is not even up. It's like turning off the switch. So this port is already down and down. So that is the disabled state. The next state is blocking state. So what does the blocking state do? Initially, when the device comes up, when the port is up, when the port is up, initially it will be in the disabled blocking state. So initially when it starts, both the ports will be in the blocking state. It starts with blocking and blocking state. So whenever I did no shut on this port, like whenever I put the power on this port, it will be in the, both sides will be in the blocking state. That is the first state. When the device is up, let's say when the device interface is up and connected, it will first enter the blocking state. So this is the second state. After that, third state is called listening state. So what does the listening state means? Both the interfaces in this state will start sending the BPDU. So switch A will send the BPDU, switch B will send the BPDU. In that state, both the switches will start sending the BPDUs and listen for the BPDUs. Both switches will start sending BPDUs and start listening the received BPDUs. Okay. What is the next state? The next state is learning state. So in the learning state, the switches will receive the BPDU with a superior, and it will start sending its own BPDU, and it will start listening from the superior. For example, after exchanging the BPDUs, let's say this guy sent the BPDU. So this guy sent the BPDU with value of 120 in the listening state. This guy will send the BPDU of value of 110 in the listening state. So both of them send the BPDUs. So what will happen in the learning state? Learning state, So now the switch, whichever received a superior BPDU will stop sending any more BPDU messages and will start listening to superior. So in this case, superior means what? Root bridge. So in the learning state, both of them will see which one is superior, and if in this case A is superior, no, sorry, in this case B is superior because the lower priority wins the election. 110 will be the lower one, so this one will become the root bridge. So A will start listening to B. So always remember, guys, smallest priority wins, not the highest priority. Before in our example, 100 is the root bridge because it has the lowest priority. 110 is the next one and 120 is the least prioritized because it has the highest value. So in this case, 110 will be the superior or the root bridge. And what is the last state? The last state is called forwarding state. In the forwarding state, the port that is elected on root bridge will start forwarding packets. Okay, so in this case, the port that is elected on the root bridge, in this case, let's say B, this port will start sending the packets. The other side will listen the packets because this one will be on the forwarding state of the root bridge. So these are the different states of root bridge election. So to elect the root bridge and to forward the traffic, it will go through 5 states: disabled state, blocking state, listening state, learning state, and forwarding state. Any questions? Questions. Okay, moving on. Next is port roles. One second, guys, let me clear this. Okay, so let's talk about spanning tree port roles. Again, same thing. 3 switches. They're all connected here. So switch 1, switch 2, switch 3. Priority is 100. Priority is 110. Priority is 120. So tell me, which one will become the root bridge?
Switch one.
Which one?
Okay, because
Of low priority.
Priority is low, which is 100 compared to the other two.
yeah, in the same example, right? So we took the spanning tree, root bridge election will happen. So that one will become the root bridge and that will start sending the packets out. So what is the port on the spanning tree called? What is this port called? This port is called designated port. So all the ports that are on the root bridge are called designated ports. So these are the ports on the root bridge. So let's write that down. This is all theory, guys. That's why I'm writing this down. Designated ports. The ports that are on the root bridge are called designated ports, DPs. What is the port that is closest to the root bridge? So in this case, what are the ports that are close to the root bridge, guys? So the ports that are close to the root bridge are this port, because this one is closest to the root bridge. This is root bridge. And this port is closest to the root bridge. Okay. So these ports are called root ports. The ports which are closest to the root bridge are called root ports. Ports that are closest to the root bridge. That is called a root port. So in this case, what is the root port, guys? So this one is the root port. This one is the root port. Next up, so this now the election happens between switch 2 and switch 3. So because of this port, because of the priority, this one is the next lowest priority. So this one will be the next selected root bridge if something happens to this one, right? So now this port will be the root port because this is the second criterion. And what will be this port? This is called alternate port or blocked port. Alternate port or block port. So the port that is in blocked state is called alternate or blocked port. Yeah, you got the idea. So these are the port types. Okay, you can also call this as backup port, something like that. But that's what the port types are. So we discussed about the spanning tree states. We discussed about the spanning tree port types. Okay. Questions? Okay, moving on. So this is about the spanning tree. This is also called as common spanning tree. Common spanning tree means this is the first version of the spanning tree. There are different enhancements or improvements in this protocol. But let's talk about the abbreviation of the spanning tree in the standard, right? So it is also called as 802.1D. Common spanning tree. It's just again, so this is 1980, February 2nd, something. 1980 February, and then 1D is the number. It's called common spanning tree. So again, the name. Some in the interview they might ask, like, tell me what is 802.1D standard. You can tell it's a common spanning tree or the regular spanning tree. And they might ask you, like, what is a designated port, or what is a root port, or what are the states of the spanning tree? Those are the basic questions that you will see in the CCNA exam or in the interview. Just for the books, right? Next up, let's talk about the enhancements in the spanning tree. So we'll talk about the rapid spanning tree. So rapid spanning tree, what is the rapid spanning tree? So let's talk about spanning tree timers first. So we discussed about the states, right? But let's talk about the timers in each state. So for a spanning tree to converge from down state to all the way to the forwarding state, or the blocking state, it takes almost like 50 seconds. For example, to talk between switch 1 and switch 3, switch 2, to elect the root bridge, to send the BPDUs, to elect this as the designated port, this as the root port, this as the root port, this as the blocking port. This takes almost 50 seconds. Let's say I'm a user. I want to try to go to, let's say, my CCNA page. If my link go down and if it comes back up, it takes almost 50 seconds to converge, meaning like to move the traffic from this link to this link, because the path should take via this way and to go out to the CCNA page. Even though this one is the root bridge, if this link go down, the BPDU exchange will happen again. The BPDU update will be sent. It will not receive any update packet from this root bridge. The 3 will start sending the packets to switch 2, and the switch 2 will be sending via this link 2, and then go to the CCNA. But it takes 50 seconds to converge, meaning like if something go down to comes back to the backup path, it takes almost 50 seconds. Okay. How can we improve this? Any ideas? How can we improve the timers in each state? Right? So, for example, the spanning tree, the blocking state does not take any time because it's already down. Next, the second state, the disabled state is already down. No timer. The blocking state, it takes roughly 2 seconds to put the port in the blocking state. To listen and learn the BPDUs, it takes 15 plus 15, 30 seconds. So in the listening state, it takes 30 seconds. In the learning state, it takes 30 seconds. So total 32 seconds. And the forwarding state will take 15 seconds more, 15 to 20 seconds. So that makes it 47 to 50 seconds, that range. So how can we improve this, right? So we can reduce the time on listening and learning. So when the switch is learning its BPDU from the other neighbor, why should it wait 15 seconds to listen and learn? It can immediately improve the time to not wait for 15 seconds to make sure it listens and settles down. So in the rapid spanning tree, they improved that behavior to make this to almost like a millisecond and a millisecond. So when you immediately turn on the port, they will send the BPDU. When it gets the response, all the process will happen in a millisecond. So we can almost bring up this 50 seconds time to roughly 4 seconds to 10 seconds in that time frame. So in the rapid spanning tree, we are reducing the time of each stage. When I mean the switches became more capable of sending and receiving the packets because of more capable links came. The ASIC got more and more deliverable. For example, let's think you bought an iPhone, like iPhone maybe 6. The processor is slower, but if you buy an iPhone 13, the processor is a lot faster. How does that happen? Because the ASICs are better in packet switching. Similarly, in the switches, they got better packet switching. So they were able to reduce the timers of the spanning tree because the switches are a lot more faster these days compared to the old switches. That's how they can reduce the time in the rapid spanning tree. So they were able to reduce the 50 seconds to almost 4 to 10 seconds. So they will ask you like, what spanning tree is better? Is it common spanning tree or rapid spanning tree? What are you going to prefer in your network? The answer is straight away rapid spanning tree, because the rapid spanning tree can reduce the time of convergence. So when there is a network outage, to re-elect the root bridge faster, to make things quicker, to make the outage less for the users, a rapid spanning tree is used, and it is better. Questions? Questions, guys? No questions? Is it clear? Well, let's see. Varun, can you tell me how much time we can save with rapid spanning tree?
Almost 45 seconds.
Yeah, you can save almost like 45 seconds using the rapid spanning tree. Let's
Yeah.
also talk about standard. So it's called 802.1W, which is rapid spanning type. Okay, so that's the standard rapid spanning tree. Next up is per VLAN spanning tree. Let's clear this. So what is per VLAN spanning tree, guys? So in the rapid spanning tree, what are we defining, right? So we define the priority. Like for example, this switch priority is 100, this one is 110, this one is 120. So this priority is at the switch level, meaning if you define the priority to the switch, that will be applicable to all the VLANs, like VLAN 1, VLAN 2, VLAN 3. How many VLANs you created, that will be applicable to all the switch, all the VLANs in the switch when you define the common spanning tree. In that case, this port will be allowed, 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 but this port will be blocked. So all the VLANs from, for example, let's say there is a PC1 and there is a PC2, there is a PC3. This is in VLAN 1, this is in VLAN 2, this is in VLAN 3. So for all these VLANs, the only common path is going via this link and then going to the destination. This path is already blocked, right? So we are not making full use of this topology, because for all the VLANs, you are making always this path, but this path is sitting idle. It's waiting for this link to fail, and then only it will take over. We don't want that. We wanted to use load balancing. How can we do that? Instead of we defining the priority at the switch level, we can define the priority at the VLAN level. For example, for the VLAN 1, the priority can be 100. And for the VLAN 2, the priority can be 200. So in that case, for VLAN 2, which one will become the root bridge? This one will become the root bridge. So then this switch, this PC can go via this link for VLAN 2 and then go to the, that can go to this way and this can go to this way. For VLAN 3, let's say priority is 1 here. So for VLAN 3, this one will become the root bridge. So the path should always take via this way, and this can go this way and this way. So what can this will help us is, instead of
Reducing the traffic.
I'm sorry.
Reducing the traffic on the single path.
Exactly. We are reducing the traffic on the single path. We are making sure we are effectively using all of our resources. We are making full use of the network. So let's say we wanted to use see like 3 videos, 1 video here, 1 video here, 1 video here. So sending all the traffic via this link is not a correct method, but we can send 1 video over this link and 1 video over this link. So we are reducing the load of the links and we are sharing the load accordingly to both the switches. So this is called load sharing mechanism that can be used by per VLAN spanning tree. So using the per VLAN spanning tree, we are setting the priorities of the root bridges per VLAN, not at the switch level. But in the common spanning tree, that is not possible. The common spanning tree is only per switch level. There is no enhancement in the common spanning tree. That's why they came up with a new protocol, which is per VLAN spanning tree. But what is the disadvantage of this, guys? What is the disadvantage with this per VLAN spanning tree? Any ideas?
I mean, one is choosing the longest path, so the speed will be, there will be less speed.
No, I mean, let's consider both of them are same speed. In that case, do you think any of the disadvantages?
I mean, when both are working, like one may go down, right? Oh,
No, I'm talking when both the links are up. When
Yeah.
you are separating the traffic to both the links, do you see any disadvantage there? Yeah, before we move on, let's write the standard of this one. So it is called 802 dot, let's say done for VLAN. I cannot type now. Spanning tree is called 802.1Q. So per VLAN spanning tree, 802.1Q. But the disadvantage of this one is, let's say there are 2000 VLANs. So as an engineer, you have to choose the priority of each VLAN. The switch has to think, okay, for VLAN 1, I have to take this path. For VLAN 2, I have to take this path. For VLAN 3, I have to take this path. So this is a lot of overhead on the CPU of the switch because you are creating 2000 spanning tree instances for 2000 VLANs. That is hitting your switch control plane because you are making the switch to think more and more to make the decision. It's not easy for the switch to calculate 2000 spanning tree instances. So every VLAN has one spanning tree instance. So that is a lot of overhead on the switch. That will make the performance of the switch not very useful. So that is the disadvantage. So that's why there is an improvement that is called multi-spanning tree. So what does this multi-spanning tree? What does this multi-spanning tree does is it will group the VLANs into multiple groups. For example, let's say there are 1 to 100, 2 to 200, 3 to 500, like that. So you are making the VLANs into multiple groups. So for the group 1, you can put the priority and elect this as the root bridge. For group 2, you can send this as this root bridge. So instead of having 2000 instances, you are making them into like maybe 10 instances of spanning tree because you are making them into groups and you are assigning the traffic over one link over the other. So in this way, you are also achieving the load balancing and also you are reducing the number of spanning tree instances significantly by making them into groups. You can always make them to two groups, like 1 to 1000 to one group and 1001 to 2000 in a different group, and you can send 1000 VLANs on this one and another 1000 VLANs on this one by electing different root bridges. So you are reducing 2000 spanning tree instances to 2 spanning tree instances. Clear, guys? Is that clear? So the standard of this one is multi-spanning tree. Is 802.1, yes. So these are again just the standard names that you have to remember. Maybe some people they will trick you. They will ask you, tell me about 802.1s. Then you should thinking, okay, they're talking about multi-spanning tree. This is just a trick question. Sometimes when the people they want to test your book knowledge, they might ask you this. Depends on who you are sitting in interview with. So that really depends on the interview day that you are on, the job you're going to with, right? That can be totally different. So that's about that. So let's do a quick summary. We will start a round robin. Mahit, can you tell me what are the disadvantages of the spanning tree?
Can you repeat the question?
What are the disadvantages of the spanning tree?
Are you asking in freelance?
No, I was asking in a regular common spanning tree, what are the disadvantages? It's okay, we'll move on. Maunika, can you tell me what are the common disadvantages of the spanning tree? The regular one, the first spanning tree.
The main disadvantages of spanning tree is like it closes off possible paths for data to move from one network to another network. Like it will have like issues like loop.
Yeah, you're saying it will close out the options of load balancing.
Yes.
It will block one of the port.
Yes.
What is the other disadvantage, the significant one? That is one. But what is another one?
Okay.
Can you try that?
Yeah, like it will take long time.
Yes, it is very, very slow. It is very
Yeah.
slow because the listening learning states will be slower than the other protocols. That's why it is very slow. When there is a network outage, the convergence time should be faster. Okay, Divya, how can we achieve load balancing? With what spanning tree we can achieve load balancing?
Um, uh, I'm not sure. I think it's round robin. We can achieve it.
No, very wrong guess. Out of the box.
8021Q.
Yeah, 801Q is one. And what about the other one? Can you not achieve with the 1S?
Yeah, one S as well.
With 1S, right?
One S as well.
Yeah, 1Q and 1S.
First thing is like setting up the priorities.
Yeah.
Yeah, one
In
Q
the 1Q, you can define per VLAN, like one VLAN over the other. You can achieve that. But in the multi-span tree, you are grouping them into multiple groups, and then you can achieve the load balance there as well. So it's both 1Q per VLAN spanning tree and 1S multi-span tree. Yeah, both. Thank you. Mohit, what are the spanning tree states?
I really don't know. Like everything was above my head actually.
Fair enough. I think this is your first class. I understand that.
Yeah, I was just thinking the question also.
Okay, that is fine. I think I can pass it to Sai Shri. What are the different states of spanning tree?
Okay, so we have total of 5. One is disabled state, blocking state, listening, learning, and forward.
Okay, can you summarize them like briefly?
Sure. For the first one, so both the ports will be like shut down by the administrator. even before like starting up. And in the blocking state, so when the device is up and connection will be in the like blocking state. And the third one is like when the switches will start like sending the BPDU, then it will receive those BPDU from each switches. And in the like learning state, after receiving the BPDU like priority numbers, so the what is it? Highest one will listen to the root bridge, and the like forwarding is nothing but the port is elected.
Okay, perfect, spot on. Thank you. Okay, I think Shruti, can you tell me what are different port types?
Yeah, the first one is designated port, and the second one is the root port, and the third one is the alternate port of the block port.
Okay, can you brief them?
Yeah, so the ports on the root bridge are called as designated ports, and the ports which are closest to the root bridge are called root ports, and the alternate ports are like the ports which are blocked.
Okay, yep, perfect, rock on. Okay, so that's a summary, guys. So the spanning tree we discussed today about what is common spanning tree, how does it elect the root bridge, how does the switches exchange the priorities, how does it elect the root bridge, right? And then we saw that there is a slowness in the spanning tree that is rectified with the rapid spanning tree. So rapid spanning tree reduced the listening and learning times, and it reduced almost like 45 seconds, 46 seconds, something like that. It reduced the time in convergence, right? So when there is an outage, we don't no longer to wait for 1 minute, almost 1 minute, to make sure our network comes back up. So in the real time, let's say someone is doing a credit card payment, we don't expect 1 minute of network downtime. So all the credit cards payments will fail in that time. So we don't want that. Those kind of networks are very critical. So that's why we don't use we cannot use the common spanning tree there. Similarly, when talking about sorry, lost the thought. When talking about the rapid spanning tree, we are reducing the timers and it is faster. And next thing is the per VLAN spanning tree. So in per VLAN spanning tree, we can load balance both the links because we wanted to make sure that we use our network efficiently and we need to load balance the traffic between both. So that's why we can use per VLAN spanning tree. Next up is multi-spanning tree. Because of the disadvantage of the per VLAN spanning tree, because in the per VLAN, we have to create more number of spanning tree instances that is causing overhead to the switch and it is affecting the CPU. Sometimes it is not the right way to calculate the spanning tree for each VLAN. So that's why the next step is multi-spanning tree, where we are grouping them. We are grouping multiple VLANs into one spanning tree group, and we are assigning the priorities to that group. That is the multi-spanning tree. Questions, guys? Any questions? Everything clear? Okay, I think that's good, guys. I think we can give it a segue there. We covered almost all switching topics except the port security that we will discuss maybe later part of the course. So today we purely focused on the spanning tree. So sync that in. We'll start routing from tomorrow. We'll start about the gateway reachability again one more time, and then how the gateway from there, how does it reach us to the next hop. We'll talk about like layer 3 component like IP address, and I think we already talked a little bit about it, but we'll talk more on the routing side part of it. So we'll talk about I think the syllabus wise, they does not cover more into the advanced routing like BGP, but I think they cover a minimal routing like static routing, and also a little bit on the OSPF, a little bit on the EIGRP. But I don't think BGP is much covered in the CCNA, but BGP is very important. So there is no network without BGP. Even like a small two-story building will have a BGP because of the sensitivity like that. So yeah, BGP is important. So even though it's not in the syllabus, I think it is very essential. We have to give at least one class, maybe 2 classes. I don't know how much deep we can go there to BGP. So that's the plan, guys. So let me stop the recording, and then we can open the floor for questions.